This is problem number 8 from section 9.6. In this problem, they say, let the system below be represented by the matrix equation AX equal B, where A is the coefficient matrix, X is the variable matrix, and B is a constant matrix. Solve the system by finding A inverse, and then using the equation X equals A inverse times B. All right, so they're saying, we did this in the previous two problems, but they're saying, make this system of equations into a matrix equation AX equal B. So let's do that. They already said A is a coefficient matrix. So A is 5, -1, 6, 1. B is the variable matrix. No, B is the constant matrix, which is 14, 30. And X is the variable matrix. Don't get it confused with little x. X is the variable matrix, which is, in our case, we got two variables, X and Y, so it's XY. Now, if we set this up like they want us to, it looks like so. So we have 5, -1, 6, 1 times X, which is XY, and that equals 1430. Okay, remember this is A times X equal B. Now, real quick, just to kind of see where we're going. If I do A times X equal B, I'm solving for the variable matrix, of course. In order to get rid of A, I have to do the A inverse of each side. When I do the A inverse of A, I get X, because these cancel to be the identity, so they're gone, equals A inverse times B. Now I got to kind of watch how I write this. Technically, I should have wrote that on the left side because we don't always know that matrices are commutative, right? They're not always commutative. So I should actually have had that flipped around there. A inverse, this would have been A inverse times B like it is there. So that was my bad. But that's what we're going for. If we do the inverse times the constant matrix, we're going to get what our X values are. We're going to solve the equation. So the first thing we need to do is take the A equation and find the inverse. So here's what we do. A inverse is going to equal 5, -1, 6, 1, conjoined with 1, 0, 0, 1, right? We need the identity matrix out here. We're going to use Gauss-Jordan here. So I'm just going to write that here, Gauss-Jordan, to find the inverse. First thing I need to do is take the top equation, multiply it by -6, row 1, and the bottom by 5, row 2. That's going to give you -30, then that'll be +6, -6, 0. And then the bottom would be 30, 5, 0, 5. Now we're going to take and we're going to add row 1. I better put the line there. We're going to come down here. We're going to say row 1 plus row 2 equals row 2. So when we add those, we get 0, 11, -6, 5. And then actually at the same time then, I'm going to take this back to what it was originally. I'm going to multiply it by -1/6 R1. So we end up going back to 5, -1, 1, 0. Now I need to cancel out this piece to be 0. So I'm going to multiply by 11 on the top. So 11 R1. When I do that, I get 55 minus 11, 11, 0. On the bottom I get 0, 11, negative 6, 5. Now I'm going to add row 1, or row 2, plus row 1 is going to equal row 1. So when I do that, I get 55, 0, negative 6 to the 11 will give you a 5. And this will be 5 as well. On the bottom, I get 0, 11, negative 6, 5. So last step, I need to take 1 over 55 times row 1, and I also need to do 1 over 11 times row 2. That's going to give you 1, 0, 5 over 55, right? Because we do 1 over 55 times 5, that's 5 over 55, which reduces to 1 over 11. 5 over 55, which is 1 over 11. And on the bottom, we'll get 0, 1, negative 6 over 11, and 5 over 11. Okay, so we know what A inverse is now. So A inverse is 1 over 11, 1 over 11, negative 6 over 11, and 5 over 11. All we've got to do now is set up this equation here and then do some multiplying. So I'm going to slide up just a little bit. And we're going to do some multiplying. So the x matrix, gotta make sure I keep it on the page. So the x matrix is xy. So we're going to set this up as xy equals A inverse, which is 1 over 11, 1 over 11, negative 6 over 11, 5 over 11, times b, which b is 14 and 30. Now remember, this is a 2 by 2 times a 2 by 1, so it works out. We're going to end up with a 2 by 1. All right, let's go through and do the multiplication. We're going to do this in the calculator, so I'm going to kind of cover up some of this work so we can work through it with the calculator. We're doing row 1 times column 1, so 1 over 11. Now use the fraction button to do this. So 1 over 11 times 14 plus, we're going to go fraction button again, 1 over 11 times 30. That gives you 4 for x value. And then you go negative 6 over 11 times 14 plus 5 over 11, fraction button again, times 30. And that's 6. Now remember, x, y equals the multiplication between these, which means x is 4, so we can write that out here. We get x equal 4 and y equals 6 for our solutions. We can check those to make sure that those are right up here. 5 times 4 minus 6 is 14. So 5 times 4 is 20, minus 6 is 14. And 6 times 4 is 24, plus 6 is 30. So we have our solutions right here, x equals 4 and y equals 6, and we did it using matrices and using the inverse.